Good afternoon, everyone. This is Fritz Ken. I hope you got to spend some time with Dr. Lamos in our last session, general session, and as well as the other sessions this morning with Bob Herman, and you got to hear from Dean, who we're going to hear a little bit more from this afternoon, as well as the poster sessions. I got to take a look at some of the photo booth opportunities there, and they are looking really, really good. If you haven't done that yet, if you want to do a group shot or post a group shot in there, that would be fantastic. That sort of makes this somewhat boring format a little bit more fun and a little bit more interactive. So thanks for your participation, your ongoing participation today. I think we put on as good a virtual conference as you can get here. The sessions have been really, really good. The feedback and interaction has been really good, and continue to use all the features that the platform allows for. So if you want to talk to folks directly, you can do that, schedule those meetings, and then go back and look at the things that maybe you didn't get a chance to see. If one thing I'll throw a shout out, if you haven't seen the presentation on PFAS and you want to know more about PFAS, that was a very thorough and technical discussion about the whole situation with PFAS. It'd probably be worthwhile if you have an interest in that to go back and take a look at it. So, but now we're going to talk about one of our favorite subjects, something that we all either love or hate at our facilities. It's something that we struggle with. It's a long-standing regulation that on the surface seems relatively easy, but in our complex process equipment, it can be very challenging and somewhat difficult to do well all the time. It really, the devil's in the details. And what Dean has helped us with, and we really appreciate his insight over the last few years and his real passion around lockout, tagout, and some of the things that P66 has done to lead the industry in this area. So with that, today we have Dean Minatas. If you were in the other session, you know that Dean has a long career, 43 years in the safety world. He's a graduate of Colorado State University, has worked for both ConocoPhillips and Phillips 66 in basically all of the HES disciplines: occupational health, process safety, environmental. He's an HES leader both for his company and for the industry. So with that, I'll turn it over to Dean. Dean, thanks for being here today.
Yeah, cool. Thanks, Fritz. So, as Fritz said, right, energy isolation, lock, tag, try, it's been around for 50 years at least, right? I mean, OSHA came up with a standard in the 80s. It seems like, well, what's so difficult about this? But yet, we still haven't solved the mystery of how to prevent incidents related to the sudden and unexpected release of hazardous energy. And, it's plagued me for most of my career is how do we stop these energy isolation related incidents? So, we've done a lot of work around this. I'll share a few things about what our Safety and Health Committee, the AFPM Safety and Health Committee, is doing. And, I will be happy to entertain. I got plenty of time at the end of this for any questions or specific questions. And so let's get started, right? So let's go to the next slide, please, Laura. So, as you know, in the AFPM, we have a serious incident reporting investigation process. We call them Tier 1As, Tier 1Ps. In Phillips 66, we've been using such a system for the last 9 years. So, you'll see on the left some data. The data says, how many serious incidents there have been, how many of them have been without consequence, and the kind of consequences there have been, whether it's release, spill, injury, or fire. Now, 30% of those, right, so anywhere from 40 to 60 had some kind of lock, tag, try kind of impact, right? Imagine that. 30% of your serious incident related to lock, tag, and try. You go, how can that possibly be? And then, you know, when you look at the graph on the right, this is data. There's no scale to it, so don't try to figure the scale out. On what were the common types of Tier 1A or Tier 1P incidents reported to the AFPM as part of the pilot program, energy isolation came up as one of the top causes of serious incidents, actual or potential. So what do you do? What do you do if most of your incidents have some kind of lock, tag, try kind of impact? Next slide, please. So we looked at it a little closer. We said, as we analyzed, we went through every incident, right? We said, my gosh, over 5 years, we had 117 incidents. That's way too many. Some of them were worker injuries, lost workday cases, recordables. Some of them turned out to be Tier 1 and Tier 2 process safety events. Some of them caused releases. So part of our environmental program, we had environmental releases. So clearly, you know, it tells us right away, we have to do something about this. This is way too much, way too many. So what do you do? Next slide, please. Well, so we have this philosophy that says, well, what gets measured improves. So we did something new, different, unique, something I guess that maybe not too many of you have. We actually created an energy isolation metric. We called it an energy isolation event. It's not very sexy or exciting, but basically we rolled this out in our company, just like our recordable injury metric or lost workday case metric or serious incident metric, right? We had a energy isolation event metric. And basically we had two categories. One of them is a level 1, which is actual, something happened and hazardous energy was unexpectedly released. So that's a level 1 where somebody opened something up, something, you know, did something, somebody opened a bleeder, a valve, it broke into a line, cut into something, something happened that released hazardous energy. And then we had a level 2, which is basically mostly administrative stuff, where we identified that, you know, maybe there wasn't proper verification done. Maybe they didn't use a lock, or maybe they used the wrong kind of lock. Maybe they didn't lock the lock. Maybe they locked in the wrong place. Maybe they didn't tag, or they used the wrong tag, or they didn't sign the tag, right? Or maybe the work permits didn't have the energy isolation pieces to it. But basically, we created this new metric. And you say, oh, gee, you know, thanks a lot. This is more administrivia. Well, you know, we tried to make it not very painful, right? So I actually, every one of these things, I'll send a note back to the site, back to the individuals reporting it and say, you know, thank you for reporting this, right? Because this is how we get better, right? You know, and we actually modified, we have a database that we use for all incidents. We modified our database to include energy isolation events. Again, there's really not much consequence, if you will, for reporting one of these things. We thank people. In our weekly refinery manager meetings, we discuss energy isolation events. We talk about these as part of our serious incident program. And we get a monthly report by site that says, you know, what kinds of level 1s, what kind of level 2 energy isolation events do we have? Next slide, please. So all of a sudden, you know, there's a whole lot of stuff that we really didn't even know was happening. And I'd venture to say in your company, right, that you probably have something similar going on, right? Where you have energy isolation things that are not going the way you want them to, but are you really learning? Is anybody reporting? Is anybody investigating? Is there any kind of follow-up to understand, are we doing this well or not? Because when I think of energy isolation failures, typically it's not good, right? Where people come in contact with process, and how many people have been hurt seriously or burned or exposed to materials because they came in contact with process. And that's what I'm trying to prevent. So let's look at some of the data that came out of the energy isolation event. Next slide, please. So this pie chart kind of shows what did we learn? And these are incidents with consequence. This wasn't just an administrative thing. These are things that happened, energy isolation failures that had some kind of consequence. It may have been a release, an environmental thing. It may have been an injury, right? So we kind of broke it down by a number of days. And so like every 2 months, we would have an incident with consequence where somebody didn't verify zero energy before opening equipment to atmosphere. Every 2 months, somebody was doing that, and it caused a problem. Every 3 months or so, we were having an incident where the work permit requirements were not followed, causing a consequence related to energy isolation. Every 100 days, we were having some kind of procedure non-compliance, where people weren't following the procedures that caused a failure in energy isolation. That's once every 3 months, right? Don't like it. Think about this next one, opened a wrong line. What happens in a petrochemical plant or refinery if you open a wrong line? I can assure you, nothing good's gonna happen when you open up a wrong line. Something that's pressured up, something that has hazardous materials in there, something that has flammables or toxics. It's not a good thing. And then every 118 days, we had some failure of the blinding process. Blinds were removed, blinds were installed in the wrong place, right? So do you know what's happening in your business? Can you sit there and articulate, do you know what people are doing when it comes to energy isolation in your business? Well, we thought we did until we started coming up with a different metric and started reporting and following up and going, gee, there's a whole lot of stuff going on here that we didn't realize, and we don't like it. So then let's take the incidents without consequence. These are things that we're lucky that nothing happened. Next slide, please. So these are all incidents, but fortunately there wasn't a bad consequence. Every 5 days, somebody had an incident related to not verifying zero energy. Every 5 days. Every 8 days, we had some kind of incident related to work permit failures involving energy isolation. They permitted the wrong line or failed to do the right kind of joint job walks or something, right? But an incident. Every 10 days, right? Where we had some kind of confusing process or procedure that caused an incident. And this next two really scare me. Every 11 days, a wrong line or an unpermitted line was cut or opened. An incident happened and we were just fortunate there wasn't a nasty outcome. And then lastly, once every 3 weeks, we're having blinds were installed improperly or in the wrong location. So it's kind of a wake-up call for us, right? Call to action says, okay, you have all this energy isolation stuff going on. What are you going to do about it? So we did a bunch of stuff, right? So the first thing, which is, I'm sure all of you already have this, right? We kind of build these set of life-saving rules. And we communicated the hell out of these life-saving rules across our company. Kind of said, this is what's got to happen. Everybody's got to verify. Everybody's got to do a joint job walk, right? This is the most important thing we do. If you don't do these things, you stop, period, right? So we just hammered that home go to the next slide, please. Hammered that home in a very big way, right? Through life-saving rules that this is important. And, I have a dozen refineries in my company. And sometimes, if I were to get people from each one of my refineries in one room and ask them what time it was, we couldn't agree what time of day it was. But here we came up with a very prescriptive procedure that we drove across every one of our refineries. And I'll talk about some of the rigorous requirements, and every one of our refineries had to do the same stuff. And we created this new metric, right? And we started reporting this metric and started investigating and started fixing and started understanding exactly what was going on. And we reviewed these energy isolation events with leadership. And then we said, you know what? We got to go check. And so we had a team. I was on the team. There's two of us. That we went to every facility, the same people at every facility, and checked their energy isolation stuff, their procedures, their training, how they're doing their lock boxes, how they're doing their joint job walks, what their paperwork looked like, et cetera, to try to intervene to stop all these energy isolation events. Well, let me tell you about our procedures, first of all, right? Our prescriptive procedure. Go to the next slide, please. So something that many of you probably look at me like, what the hell are you doing, right? We required locks to be put on blinds in process piping. OSHA doesn't require that. OSHA says, well, if you got to have tools to take it out, that's really not what the intent was. Our thought was, well, when you're telling people to go out and remove a bunch of blinds, if they walk up to a blind and there's a lock on it, then they should know, hey, don't touch this blind because it's locked. Seems logical. Well, we did it. And that was not a popular decision. People didn't like locking blinds. Operators didn't like locking blinds. Craftsmen didn't like it, but we started doing it. And I'll show you the results here in a little bit. We were having energy isolation events where hot or plugging materials like vac resid or catalyst or whatever, people thought something was isolated. It was hot, but it is plugging service. And we created specific procedures for hot materials and plugging service so that we don't burn people when that plug decides to set free. And we have several of these things. So I don't know what you're doing around hot or plugging materials, but if you don't have some specific protocols in place, I suggest you look at that. Because we've had several incidents in my company over the years where people were burned because they thought something was isolated until that plug broke through and caused a release. We no longer allow a live flare open. If you're going to get into the flare, the unit has to be shut down, period. Big step. It's hard, but we did it. And it works. If anybody's going to break into a line, if we're going to open up a line, break a flange, install a blind, we have established criteria that has to be met before somebody can even open it up. And we have to test through a bleeder or what have you to make sure that that criteria is met. We have criteria for LEL, for benzene, for H2S, or other hazardous materials, or maybe it's for steam, right? So the operator has to test in a bleeder or low point to find out that it's clean and ready to be opened. And if it's not, then they have to do some more cleaning so that it's safe before it's opened. Because I can't tell you how many times people opened up a line to find out it's still under pressure or still had nasty materials in it. So we established atmospheric criteria for initial openings. Well, you say, well, what if there is no bleeder to be able to open up and test? Well, then that's the next bullet point. That basically we said, okay, we have a safe work plan. And the people opening up that line and operations has to work on a safe work plan. And that has to be approved by the refinery leadership team before they're allowed to do that. So we made it a very big deal in order to open something that doesn't meet our atmospheric criteria. These steps have created a pretty big chunk of work, but have prevented a lot of incidents from happening. So in our company now, we have a couple of new processes that basically says, if you're gonna go break a line somewhere, there's no tag on it, walk away. No tag, no break. There has to be a break tag on that flange that you plan on opening. It was a pretty significant step. We also, people have, they want to cut certain. Well, we had people cutting the wrong line. So what do you do about that? You can't put a tag on a line. It's kind of hard. Well, we use cut tape. So before you're allowed to cut on any line, there has to be cut tape there, and the same criteria has to apply. We have to make sure that that line is depressured, doesn't have LEL in it, doesn't have benzene in it, doesn't have H2S in it, doesn't have steam in it, etc. And lastly, we adopted all the walk the line kind of stuff that the AFPM had been talking about over years. So before we ever introduce process back into material that have been into process units that have been shut down, we first of all, we like to pressure test wherever possible to make sure there's nothing left open. There's no valve or bleeder plug left open. And then we do a double independent verification to make sure that that equipment has in fact been totally closed and is ready to receive hazardous materials. So everybody had to do these things. This was not popular. I don't know too many people that liked it, but I don't care, right? We have to do the right things, sometimes unpopular, to prevent release of hazardous materials. And we thought these things would make a difference. Let's talk about some of the things we learned when we did deep dive assessments of energy isolation. So next slide, please. So I highlighted a few of them in red. So I found that at many sites, operators would isolate the equipment, and then a different operator would go check and verify and make sure that that isolation plan is appropriate. This is before craftsmen were even there to get a permit to do work. Double verifications before the work. This brake tags, no tag, no brake policy, it's a difficult thing to implement, but by God, it makes a big difference. You see a pressure test for return to service, right? That's so important to do a proper pressure test for the right amount of time so that something isn't being left open and you're not going to introduce hydrocarbons or toxics into a process pipe and have it leak or release. In our company now, anytime anybody's going to do work on materials, on process equipment where there's potential for hazardous materials to be released, we have all kinds of tags. Operators have to sign the tag. The craftsman has to sign the tag that says, I've checked the permit, I've checked the isolation points, I've checked the verification points. I've had operators complain that, well, it looks like Christmas out here. There's so many tags. Says, yeah, that's right. There might be, I'm looking at a text here. I'm looking at when we did all these tags, we wanted to make sure that people really went to every isolation point and initialed off that they were there. And they knew that was properly isolated. And that they went to every verification point and they checked and they used bleeder unplugging tools. And we know that they checked to verify that the absence of energy was there. It's a very complex thing. It takes a lot of time and takes a lot of rigor. I think there was a chat up here and I didn't get a chance to read it totally. Question is could you briefly elaborate on the steps in your procedure for opening hot or plugged materials? So the answer to that would be, first of all, there has to be a recognition if the process has higher than 150 degrees. Secondly, there is a very extensive decision tree that basically says, okay, if you got hot materials, if you got plugging materials, if you got catalysts, if you whatever, right? How do you know that basically your valves or, you can't rely on a single isolation point. If you have one single valve, that is not adequate isolation for that type of service. If that's all you have is one valve, then unfortunately we have to go beyond engineering controls and rely on personal protective equipment where we have specific PPE that has to be worn even when the valve is closed in hot plugging kind of service. So that just in case that plug were to release, the worker, the employee, the person is not going to be exposed to that hazardous material. We worked across our refineries to build this decision tree, and it's part of our energy isolation procedure that every refinery has to implement. As we did our deep dive assessments, we also identified a couple other things. If your site does not do a proper joint job walk, where the operator issuing a permit and the craftsman doing the work do not go to the site, talk about what's going to be done, show the isolation points, show the verification points, demonstrate that the verification point is actually open, then you have an opportunity to improve. The direction in our company is, if you don't do a joint job walk, you don't issue a permit. Now, there's probably times that it does happen, but we don't like it and it's against procedure. Got a question here, says, what media is used for pressure testing equipment prior to returning to service? Well, that depends on the metallurgy and the type of equipment that is being pressure tested. It may be nitrogen, it may be air, it may be water. It just depends. The process engineer has to determine what the appropriate medium is, because obviously we can't introduce air into some systems, or sometimes water can cause a certain kind of chloride stress cracking, or sometimes we use nitrogen. But basically each process engineer, they have to determine what kind of materials, what kind of pressures, and for how long to do a proper pressure test. So first thing I want to get across to you, right? And when we do health checks on our work permits, we continue to find challenge around poor joint job walks. I stress in my company, I stress to you all, focus on this. Good joint job walks end up in having good, safe work most of the time. It is a critical piece. We also found, locks missed. People aren't locking. People don't know where to lock. People leave their locks on. The isolation log sheet that we're supposed to have, sloppy, you can't read it. Right? We implemented this thing where everyone in our company, in our nested contractors, and now our turnaround contractors, we don't just rely on CBTs or ad nauseum lectures when it comes to energy isolation. We require hands-on training. And we've built these skids or these trailers, or these actually have training buildings where we have pumps and compressors and switch gear and exchangers and tanks, and we actually have props. And people have to go put their hands on and demonstrate they know what the heck they're talking about when it comes to energy isolation. They have to pass a practical test that they know what to do, everywhere from getting the permit to doing the joint job walk to verifying the absence of energy to placing their lock on that device to control the energy. And by the way, every worker places a lock. If you're doing work, you are controlling the energy. There's no tag out processes in our company. So there's a bunch of areas of concern here. I don't want to read them all to you. What I would tell you is if you're going to get good at this, you have to, first of all, start understanding what your types of energy isolation failures are. You have to start measuring them. You have to start analyzing them. Your procedures, get your teams to sit down and understand what does good look like when it comes to energy isolation, and create procedures based on the kinds of experiences you have. And then send people around to check. I use this term a lot. In God we trust, everybody else must verify. This term verification is so important in our industry. We cannot assume that somebody else is verified. We can't assume that somebody else has checked it. We cannot assume, because that's when we have incidents. So let's look at some of the results we had. Next slide, please. So initially, after we started this, you can see how many level 1 and level 2 energy isolation events we had. And after we got these procedures in place and the deep dives in place, we almost by an order of magnitude reduced them. And we reduced the level 1s significantly, almost totally eliminated level 1s where we had unplanned, unexpected release of energy. I think we made a difference. We didn't eliminate, but we sure as hell reduced a lot of these things. Now, what I find is, I have this philosophy that basically says, thumb on, thumb off. We had our thumb on energy isolation for a couple of years. And as long as we focused on it and kept the pressure on, by God, our performance improved, and we weren't having energy isolation events. And then as we got good, we said, okay, we got this. Or at least maybe we thought we got this. And we took the thumb off a little bit, and all of a sudden they started coming back. In fact, I had one today. Energy isolation event came across today. Someone cut into a tubing that was pressurized with nitrogen. Didn't cause any big deal, but the fact was that they recognized it, they reported it. It was an energy isolation failure, and something, again, we have to get better at. So I don't know if this is helping you think about what you might do in your business, but it sure made a difference in our business. And when I think about whether it's in a confined space, or I think about somebody installing a blind, somebody changing out a pump or changing out equipment, right? How important it is that before they open that equipment that it's safe to open, that they verified. You're not guessing. You verified, right? Important words. You verified, you checked. You don't assume, guess, think. It's safe. You know it. So next slide, please. I want to talk about some future work. So we implemented an electronic work permit process in our company. And basically it's kind of artificial intelligence, because the operator will select the type of work that's going to happen, and it lists the hazards of that kind of work, and it lists the controls, and the operator and the craftsman don't have to remember. They can see all the different hazards and see the controls, and helps them do a better job planning the work. So we're right in the middle right now of completing the energy isolation module for that this module will create the isolation certificate, where we'll take phones and iPads and actually use barcodes or QR codes to demonstrate we've been at that point and verify the absence of energy. And when a lock's put on, it'll build on to our isolation certificates. It is really cool and will make another difference to help our operators and our crafts be more successful out in the field. We're able to get technology to help us drive excellence when it comes to energy isolation. So with that, that's the end of my, let's see, I got 10 minutes left for any questions that any of you might have on this particular subject.
Yeah, Dean, there's a couple of questions.
Okay.
So could you elaborate on your steps or your procedures? For
Yeah, I answered those, Fritz. I saw those earlier.
Okay, you got those?
I answered both of those.
All right, cool. What else? Anybody out there? Any other questions?
So I will say that the AFPM Safety and Health Committee, you can find it on the AFPM website. We, you saw the AFPM data that basically says energy isolation failures is one of the leading causes of serious incidents in our industry. And so we've collaborated, all of us, right, on way cool, we call it this, way cool energy isolation practices. And we basically have, it's a long spreadsheet of, what did you guys do? Why did you do it? And what was the outcome? So you can either call one of us and ask questions, or you can go on the AFPM sites or ask somebody at AFPM, where's this way cool energy isolation practices? And it'll tell you what some of the cool processes are. I see a question here that says, how do you manage personal locks on larger group isolations? So that's that used to be kind of a challenge. I think we've kind of got the hang of it. But during a turnaround, we may have 500 people working on an FCC or something to isolate that. And so basically what happens is the operators will go isolate all the valves or blinds or whatever, and they'll put all the keys in a box. And that box goes into a particular area as the operations lockbox. And then we have turnaround master authorized people. They will go put their lock on that operations lockbox. So in essence now, once that turnaround master puts that lock on there, operations cannot open up that box. And then the key to that box goes into, the key to that lock goes into a subsequent box that's out in the field that the workers can, when they sign the permits, when all the permits are issued, will put their lock on the field lock box. Sometimes we actually go three different kinds of lock boxes, right? 3 deep, so that you got the operations lockbox that's locked by somebody. The key to that's put in a field lockbox, and the workers that are going to work on that equipment place their lock. Sometimes we have multiple gang lock boxes chained together with locks for people to put on there. It becomes kind of a logistics nightmare sometimes. But ultimately, we trace each person to each lock, one person, one lock. If you're working on something, you are locking it. It's not easy, but we figured it out. Are group locks used? There are times, not for energy isolation per se, but some of the electrical craft might decide to put their lock on some switch gear or electrical apparatus just to protect, let's say there's nobody working on it, but they don't want anybody to go mess with something. So I know we do use some craft locks to put on there that, that the electrical group has isolated this equipment. And so those are the only kind of craft locks we use. We say, what do you use to lock blinds? There's several things. There are bolts that go into the blinds that on the backside have an actual hole, specifically a locking blind kind of a nut that you can put a lock on there. We've done as simple things as put cable around the thing. It's really more of optics, if you will, than it is absolute prevention. Nobody can compromise that blind. But when somebody walks into one of our facilities and we say, look, dude, in your work here, if somebody issues you a permit to go remove a blind and you go there and you see a lock on it, that blind is not prepared to be removed because tags fall off. People kind of, we've had, still to this day, we have people start removing a blind without really checking, right? And so, we just thought it's another layer of protection. It's not foolproof, but it's another layer of protection to prevent somebody from removing the wrong blind. I think I have 3 more minutes, I was told.
Yep.
Questions?
Winding down. Anybody else? Questions for Dean?
Sweet. Well, thank you for the opportunity to talk about this. I'm available. You can probably Google my email or phone number or Fritz's or AFPM's or something, right? If I can help you with this, right? Safety is not a trade secret for us. I'm more than happy to help. I'd love to see energy isolation injuries and failures continue to be reduced in our industry. So thanks for the opportunity to share this.
Thank you, Dean. Good job. Okay, folks, we're getting towards the end of our process for the day. We do have one more session, the Innovation Award session at 5:15 Eastern, 4:15. I'm sorry. Yeah, I think it's 5:15 Eastern, 4:15 Central. So that's a new award that the AFPM just came out with this past year. We had our first set of winners for that, and there's some pretty cool stuff that people have come up with, and we awarded them the new Innovation Award. So please take advantage of that. Thanks again, Dean, and take a look at all of the things that are out there on the platform, and we'll see you in the next session. Thank you.